In this exercise, we will be learning how to model, analyze and design a simply supported beam. So first, in the STAADPro Connect edition, first click New. Give a file name. Say we are going to model a simply supported beam. So let it be SS beam, say 7, any number, okay, because already SS beam many numbers will be available. I am giving 7. Then the location is more important. We need to store in a location where we could retrieve the file at any stage, at any later stage. So here I have stored in D drive in a folder named SNCiv, in which there is a subfolder called STAADworks. Then we need to check the units. So there are two system of units, English system of units and metric system of units. Nowadays we use metric system, so click metric. Okay. Then click create. Now these are the things which we need to do systematically. Okay, or this we can call it as a checklist for doing this process or exercise. So first will be geometry. We need to create the geometry. We need to give the properties for the geometry, and then we need to specify the materials, then give supports, loading, analysis commands and design commands. So this is the sequence which we are going to follow for this problem. So geometry is already highlighted, in which we have what is called as structure wizard. So if you want to know about any particular icon in this STAADPro Connect Edition main screen, just move around it, the icon, move around the icon, it will display the purpose of the icon, unlike in other softwares. So here structure wizard, where we have standard templates of various structural models. We can take any one model, modify to our need, and then make use of it. Okay, so click structure wizard, in which initially it will be displaying prototype models. The model type is truss models, and various truss configuration will be displayed here. Say if you want to do a north light truss, just click and modify to our need, and then we can make use of it. Now we are interested in modeling a beam, therefore click here, click frame models, in which we have frame models as well a continuous beam model. So double click on continuous beam. So double click on continuous beam. We need to specify the length. Say we are going to give only we are going to model only simply supported beam. Therefore, let the span of the beam be 5 meters. So type it as 5 meters. And we need to specify the number of bays along length. And since it is a simply supported beam, number of bays will be 1. So to switch over from here to this, use tab option, then type 1, because we are going to give only 1 bay. Click apply. Then a model of 5 meter length beam will be displayed here. This we need to transfer to the STAADPro screen. So for that, click File, click Merge Model with STAADPro Model, click Yes, click OK. So the model will be transferred here. So this we have taken from the structure wizard template, and then we have given a length of the beam or span of the beam, and then we have transferred the model to the merged with the STAADPro model. Now, what we see here is the isometric view. So if you want to see the front view, go to view option. Here you can have various views. This isometric view. This is the top view. This is the bottom view. And then this is the front view, back view, like this. So if I want the front view, click on front view. So you can see the front. Then, what are the things which we need to display on the screen? That can be set using label settings option. So here, if you click label settings, if you select node numbers, node points, beam numbers, and node values, other things will be available by default, so leave it as such. Click apply, click OK. Now we could see the beam number. Say beam number is 1, node number is 1. This is node number, second node, so node number 2, and this black dot indicates the node points. So now, since we have selected node points, node numbers, beam number and load values, it will be displaying whatever things we have selected. So now we have created the model, line model of the simply supported beam. The next thing is properties. We are going to define the properties for this beam and make this line model a solid model. So click properties, click define. So various shapes will be displayed here, and our beam is a rectangular cross section. So click on rectangle. So here it will indicate what is YD and what is ZD. So YD represents the depth of the beam and ZD represents the width of the beam. The material by default is concrete. You can change the material if you want any material. So let it be concrete here. So depth, the depth of the beam. So we need to assume 1/10 of the span as trial depth. So 1/10 means, say, let me take 0.45. 0.45 as the depth and 0.23 as the width. Click add 0.23 as the width, 0.45 as the depth. 0.45. Okay. Click add, click close. So the property which you added will be added here. So reference number 1, section is rectangle, size is 0.45 by 0.23, the material is concrete. Now we are going to assign this property to this beam. So ensure this property is highlighted. Select the beam by clicking on the beam. So now the beam is selected. Now see whether it is assigned to selected beams. So this property will be assigned to the selected beam. Then click assign, click yes. Now it is displayed as R1. R1 means reference 1. It's of section rectangle, size 0.45 depth and 0.23 width, material is concrete. If you want to see the solid model, if you want to visualize the solid model, that can be seen here. So click view. We have 3D rendering. So the line model has now become a solid model. So the width is 0.23 and depth is 0.45. Close this window. The next is we need to give the supports. So we are going to define the supports for the simply supported beam. Say let us assume left support will be pinned and right support be on rollers. So let us see how to create the supports and then how to assign the supports. So click supports, click create. Various types of supports will be displayed. So I want pinned support. So click pinned, click add. Then another support is roller support. So create. For creating roller support, this option could be used. Fixed butt could be used. So in which we need to release Fx, release Fz, Mx, My and Mz. As we know that a roller support, in a roller support, there will be only one reaction, vertical reaction. So it will not allow to move along y-axis. Whereas it can be allowed to move along x-axis, z-axis, it can have moment about x, y and z-axis. So there is a constraint in y direction, therefore we are not releasing in the y direction. Then click add. So this will create a roller support. Now select this support. This support need to be assigned to node 1. So select node 1. See whether assigned to selected nodes is available. Click assign, click yes. So the hinged support will be assigned to left node 1. Now select this next support, that is a roller support. Now select the second node, then click assign, click yes. So here this is the roller support. We could see, say the roller support is visible here, whereas the hinge support is not visible. If you click on this support, then this will be visible, this will not be visible. If you want to display both, then we need to go to view. In view, we have display options. In the display options, we have assign dialogues. Click assign dialogues, and we need to select show all labels when dialog is open. So click this, click apply, click OK. Now we can see both the supports are visible. So initially we created the geometry of the beam. We gave the material property Now we have created the supports. Next is loading. So just click on loading, click on load case details, click add. Say here this is optional, you can give the loading type as dead load, live load or roof live load, etc. And then here you can give the title as combination of dead load, live load, like anything can be given here. Then click add, click close. Now select this load case, and then click add. So we'll be having various load options here. Say now let us assume that we are going to give a uniformly distributed load over this beam. So uniformly distributed load is considered as member load. Since it acts over the member, it is member load. So click on member load. Member load, we have various types. We have uniform force, uniform moment, concentrated force, concentrated moment, linearly varying load, etc. Just you click, you can see the what are the variables need to be given for each load category. Say concentrated force, I need to give the value, magnitude of the load as well, the distance at which the load starts. Similarly, concentrated moment, linearly varying load. So these are the inputs need to be given for linearly varying load. And if this is a varying load of this type, I need to give W3. That is, I need to select this W3 and I need to give. Because now I am going to give uniform force. So click uniform force. Here you can see W1 is the intensity of the UDL. D1 is the point where the UDL starts and D2 is the point where UDL ends. And D3, so D3 is the distance. Say if the load is shifted somewhere else here, that will happen in case of say lateral beam, main beam, lateral beam resting on the main beam at the center or at some offset. So that will shift the load from the center line to somewhere else. So that distance is D3. Here I will give W1. I'm going to apply a UDL of 30 kilonewton per meter. So give minus 30. Minus is downward because we have chosen global y direction. So give minus 30. If you simply ignore D1, D2, D3, this UDL will be applied over the entire length. Click add, close. Now if you see, there will be a question mark near the load. That means load has been added, but it has not been assigned to the member. So click on the load, click on the member, then assign to selected beams, click assign, click yes. Now the beam is subjected to the UDL of 30 kilonewton per meter. Say I want to visualize the load. Say it is actually showing to the full screen. I want to cover the beam. So you go to loading diagram. Here we have load. Click view loading diagram. So you can see the simply supported beam subjected to UDL of 30 kilonewton per meter. This is how we can give other loads also. The other loads we will be seeing in the subsequent examples. All types of loads will be covered. Then go to analysis. In the analysis, we have what is called analysis commands. So click perform analysis. In the print option, we need to select all. Click add, close. So if we notice here, what are all the inputs which have been given so far, that will be displayed here. Say the material has been defined here, the member property has been given here. If you just click on the plus symbol, it will expand. Say we have given the member property as YD as 0.45, ZD as 0.23. Then constants, supports if we click, we have given two types of pinned and fixed bed. Okay. Then loading, if we click on the loading, so member load we are given, in which we give uniform distributed load of minus 30 kilonewton per meter. We are given the analysis command. Now the design is pending. So we need to give the design commands. So click on design, select the material. Say I want to design a RCC beam, concrete beam. So click concrete. Here we need to select the code. So current code is ACI code. I want to design as per IS 456 code. So click IS 456. And now, as we told that these are the checklist for doing all the processes. Now, this side, this screen, this window will become the checklist. That is initially the current code, then select parameters, define parameters and commands. So this will complete the entire pre-processing of the simply supported beam. Pre-processing in the sense giving all necessary inputs required for a problem. So now select parameters. We have all parameters as per IS 456 code. Bring all the parameters to left side by clicking on the double arrow. Now, we are going to select what are the things which are required actually for our design. So, we'll be requiring this FC. So, click FC, press Control button and click FI main, FI secondary, maximum main, maximum secondary, minimum main, minimum secondary. These 7 parameters will be mostly useful for our RCC design as per IS 456 code. So, click OK. Now, before defining the parameters, we need to check whether the beam is selected, because we are going to define the parameters and we have to assign to the selected member. Therefore, the member is selected. If it is not selected, just click over the beam and select it and go to define parameters. Now, we need to give the FC value. Say, for example, if M20 grade concrete, the characteristic compressive strength is 20 Newton per mm squared. However, we need in kilonewton per meter squared. So, we need to divide by 1000 and multiply by 10 power 6. So, altogether, we need to multiply by 10 power 3. So 20,000 will be the units in kilonewton per meter square. Click assign. Click FI main. That is yield strength of main reinforcement. Say if the main reinforcement is of FE high 500 steel, then 500 followed by 3 zeros. Click in kilonewton per meter square. Click assign. This is FI secondary. That is yield strength of shear reinforcement or secondary steel. So let it be FE 415. So 415 followed by 3 zeros. Click assign. Then maximum size of main reinforcement. So let the maximum size of main reinforcement be restricted to 16. Click assign. Maximum secondary reinforcement. So secondary or shear reinforcement. So beyond 12 mm means it will be hard to bend the stirrups. So 12 is enough. So click assign. Then minimum main reinforcement. So minimum reinforcement, we need to provide minimum of 12 mm for beams. For slabs, 8 mm and 10 mm are okay, but for beams, minimum 12 mm is required as per the IS code. So minimum main reinforcement 12 mm, click assign. Then minimum secondary reinforcement shall be 8, click assign, close. So now we can see we have defined the code as Indian, characteristic compressive strength of concrete as 20 Newton per mm square or 20,000 kN per meter square. FI main, FI secondary, maximum secondary, minimum secondary. Now the only pending command is this commands. So click commands, click design beam, click assign. Then click on take off. Take off means what is the quantity of concrete required for this beam? What is the quantity of steel required for this? So I'm interested in that. So click take off and click assign. Click close. Now we have completed the pre-processing. That is, we have defined the geometry, we have given the member properties, we have given the support specifications, we have given the loading, we have given the analysis commands, and we have given the design commands. The next stages will be processing and post-processing. So for processing, we don't need to do much. We simply, if we click run analysis, the program will do the process by itself. By the default method, say matrix method is followed here, therefore it says performing the element stiffness matrix, global stiffness matrix, and triangulation, factorizations, they're solving equations and all. So we need to get analysis successfully completed. Click done. Okay. Now processing is over. The next thing is post-processing. That is, we are interested in viewing the results. So click post-processing, click apply, click OK. You can maximize this screen to see the results. So here we have the results MZ, My and Mx. That is bending about Z axis, bending about Y axis, and bending about X axis. So since we have model in the XY plane, bending takes place about Z axis. So if you click MZ, the venue diagram will be displayed. Now the value of the diagram, that is more important, but it is not available here. To see the value, you need to click annotate, click beam results, click, we want bending at the ends, maximum and midpoint. Similarly, at the later stage, you'll be requiring shear force at the ends, maximum shear force and shear force at midpoint. Click annotate, click OK, close. Now this is the maximum bending over 93.75 kN/meter. So this is you can very well check with the analytical calculation. In a simply supported beam, maximum bending will be WL squared by 8. W is 30, L is 5. So 30 into 5 squared by 8 will be 93.75 kN/meter. Now if you want to see the shear force, just close this and then click on shear force along Y axis. So this is the shear force diagram. Say 75 kN here, plus and minus are defined here. Therefore, this will be the shear force diagram. Then, if I want the design, beam design, what will be the bottom reinforcement, what will be the top reinforcement, what will be the shear reinforcement. So we need double click on the beam. So now the cursor available is nodes cursor. I want beam cursor. So go to select. Here we have node cursor and beam cursor. Select beam cursor. Now the cursor gets changed to beam cursor. Just double click on the beam. You can see the geometry of the beam. You can see the property of the beam. Loading. What is the loading given? Shear and bending. Say here it shows the same bending mode diagram which you have seen earlier. There is 93.75 kN at the center. That is at 2.5 meters. So this is the bending mode diagram. Why we are saying this is the bending mode diagram is, if you see here, bending Z is highlighted. So this is the bending mode diagram. And what we see in the table is the shear force and bending mode values at intervals. Say at 0 meter, what is the shear force and bending mode? At 0.4167 meters, what is the shear force bending mode? Likewise, it goes up to the end, that is 5 meter. At 5 meter, what is the shear force? What is the bending mode? So you can see values at intervals. And if you want, if a particular, if you want a value at a particular point, then you can type here. Say if I'm interested in 3.28 meters, then this will give you shear force at 3.28 meters and bending mode at 3.28 meters. Then if you click deflection, it will see the deflected shape. Here it doesn't shows the deflected shape. The reason is global deflection along x direction is chosen. Click on Y, therefore this will be the deflection. We very well know that maximum deflection in a simply supported beam subjected to UDL is 5 by 384 WL power 4 by EA. You can very well check the values with the numerical values which we have. And this is the table gives the displacement or deflection at intervals. Then if you click the concrete design, we can see the reinforcement. So two numbers of 12 mm dia is required at top, 6 numbers of 12 mm dia is required at the bottom. So this is the reinforcement, and this is the shear reinforcement. That is 8 mm rods, 8 mm dia rods at 300 mm center to center. Similarly at this end. Now the other way to see the result or output is can go to utilities. Go to utilities and you can click the analysis output. The output window will be open here. So here you can see the analysis, all options, all the things, commands which are given will be available. Say if I'm interested in beam, just click on beam, then it will give the beam design details. As per IS 456-2000, limit state method of design, beam number is 1, say M20 grade concrete, FE 500 for main steel and FE 14 for secondary steel. The length is 5000 mm or 5 meters. Size is 230 mm by 450 mm. Cover is 30 mm. This is summary of reinforcement area. The top reinforcement, bottom reinforcement. Usually we do not require any reinforcement at the top. However, two numbers of 12 mm dia bars are used as hanger bars to have the ease for construction of or providing stirrups. This 212, 412, 612, 412, 212. So actually at the center only we have maximum bending mode. Therefore 612 is required at the center of the span, and that could be gradually reduced 412 at these points and 212 at the ends, because bending mode gradually decreases to 0 at the supports and maximum at the midpoint. So this type of reinforcement can be actually provided for economical reasons. And then if you just scroll down, we can see the concrete takeoff. That is the total volume of concrete required for making this beam is 0.5 cubic meter. That is 0.23 by 0.45 by 5 will give you this. Then bar diameter. Say 8 mm dia, I require 72 Newton because the unit of weight is Newton. 70 Newton is required. Similarly, 12 mm rod, 247 Newton is required. We can convert into kg and then into tons. So that much quantity of steel will be required. So everything is available here in this STAADPro. So this completes the analysis and design of a simply supported beam using STAADPro Connect edition.